Hello, I'm Christian, a student of cognitive science at the University of Tübingen, Germany. This summer, I've had the pleasure of working with Dr. Oliver Kramer on a project on the topic of tree modeling for robotic manipulation using a 3D autoencoder. I've really enjoyed working on this project because my main research interest is the intersection of machine learning and robotics, and this project really allowed me to dive deeper into that field and to also connect with other people that share my interests. Now, the motivation or the end goal of this project is to have a robot that can do manipulation tasks on trees, such as harvesting fruits or pruning branches. And this would have a bunch of useful applications in agriculture. And a necessary first step to achieve this is to have a perception component that can generate a 3D model of the tree. And 3D modeling is a well-researched topic in computer vision. And one of the problems here is to reconstruct a 3D model given only a partial view. So for example, when you have a 2D depth image, as you can see on the right-hand side here, and you want to convert this into a 3D point cloud, you'll end up having a lot of blank space in this point cloud because some objects will occlude the view on what's behind them. And when looking at trees, this occlusion problem is especially severe because the leaves and twigs on the outside will occlude the view on the branch structure on the inside. And our approach for tackling this challenge is to train a 3D autoencoder neural network to fill in those occluded regions. And to train any kind of neural network, the single most important thing is always training data, and this is our contribution in our work. We provide both complete 3D models that we grew using simulation that simulates tree growth. And next, we took those complete 3D models and we moved them into a simulation where we um, took images of them and reconstructed partial 3D models from those images. And the idea is to now input this partial model into the autoencoder and to train it to output something that is as close as possible to the original complete model. Now, to conclude this, I'd like to share a little bit of information about me and what my plans for the future are. I'm currently finishing up my bachelor's thesis and I will graduate very soon. And in mid-October, I will start a master's program in machine learning. And I would really love to keep working on the intersection of machine learning and robotics. And one of the projects that I'm currently very excited about and that I'd like to work on next is this table tennis robot that I'm playing with in this picture here.